Okay, 1.9, inverse functions. So we're given that f of x is equal to 8x, and we want to find the inverse function of f, and we label inverse functions f and with the -1. Now, this doesn't mean it's the reciprocal, this just means inverse of f. So here's how we go about it. So I like to just start off with substituting f of x. We're going to call it y. Y is equal to 8x. Now what we want to do is switch the variables and then solve for the new y. And that is going to be called our f inverse. Okay, so first thing we're going to do is switch the variables. So we're going to say x equals 8y. Now we solve for y by dividing both sides by x. So we have x over 8 is equal to the new value for y, which is f inverse. Okay, let's look at example 1, and we're going to find the inverse of that. So f of x is 3x plus 2 divided by 5, and we want to find f inverse of x. Okay, so first we start by saying, substituting y for the f of x. Y is equal to 3x plus 2 over 5. Now we switch the variables. X equals 3y plus 2 over 5. And now we solve for y. So we're going to multiply both sides by 5. So we have 5x equals 3y plus 2. So we have to subtract 2 from both sides. 5x minus 2 equals 3y. And finally, we're going to divide both sides by 3. So we have 5x minus 2 divided by 3 is equal to y, which we are calling f inverse of x. Okay, so now we want to verify that 5x minus 2 over 3 is actually the inverse function. And we want to verify it using the identity function. Well, the identity function says f of f inverse of x is going to be equal to x. And also, f inverse of f of x is also equal to x. So let's rewrite our f of x and f inverse of x. So f of x was 3x plus 2 over 5, and our f inverse of x is 5x minus 2 over 3. Okay, so let's first do f of f inverse and see what we get. So we take f inverse, which is 5x minus 2 over 3, and we're going to substitute that for the x in f of x. And so the x is multiplied by 3, so we have to multiply this by 3, and then plus 2, and then divide the whole thing by 5. And so this is f of f inverse of x. So let's simplify that. Well, we can do that. So the 3's are going to cancel, and that's left with 5x minus 2 plus 2 in the numerator. And we have a 5 in the denominator. Well, the minus 2 and plus 2 cancel, so we have 5x over 5, which is equal to x. So that one checks. Now they both have to work for the whole thing to work. Okay, so now let's do our second one, which is the f inverse of f of x. So f inverse of f of x. First we write the f of x, which is 3x plus 2 over 5. And then we look at f inverse and see what we're doing with the x. So we're multiplying it by 5. So we have to multiply this by 5. And then we have a negative 2 divided by 3. Okay, so just like in the previous one, so we're going to cancel the 5's. have 3x plus 2 minus 2 over 3. Plus 2 and minus 2 cancel each other. We have 3x over 3, which is equal to x. So both of these check, which means that these two functions are inverses of each other. Okay, so we're going to graph inverse functions. And we're given f of x is 2x minus 2, so we want to find f inverse of x. And so we'll start off by going y is equal to 2x minus 2, switch the variables, x equals 2y minus 2, solve for y. So we're going to add 2 to both sides. X plus 2 equals 2y, and now we'll divide both sides by 2. X plus 2 over 2, and this is the inverse of x. And so we want to graph both of them. Let's start with xy table for f of x. So f of x, xy table. We only need 2 values, so when for f of x, when x is, let's say, 2, 2 times 2 is 4 minus 2, so when x is 2, y is 2. So here's 0.22. And let's do another one when x is 0. 2 times 0 is 0, minus 2, so y is a minus 2. So 0, negative 2. And that's enough to graph our lines. Let's go ahead and do that. Well, let's see. Let me extend it out a little bit. Okay, so this is f of x in blue. We'll do f inverse. We'll do that in red. So f inverse of x, we want to do xy table for that. So when x is 0, we have 0 plus 2 over 2, so y is 1. Let's put that there, 0, 1. And when x is, let's say, 4. 4 plus 2 is 6 over 2 is 3, so 4, 3 is our other point. 4, 3 right here. So now let me go ahead and draw f inverse. Call the red f inverse of x. Okay, now I'm going to draw in a dashed line that is equivalent to y is equal to x. So that's going to look like something like this. So this is this green line, we'll call it, it's going to be called y is equal to x. And the reason we do that is notice that the f of x and f inverse of x are mirror images with respect to y equals x line. So the other thing we notice is take any point on the f of x. So let's take this point right here, which is negative 1, negative 4, negative 1, negative 4. And its corresponding point on the red curve is going to be, just switch these values, negative 4, negative 1. So negative 4, negative 4, negative 1 is right here. This is negative 4, negative 1. So essentially the domains and the ranges switch. The other thing that's interesting on this is you can draw a perpendicular line from the point to y equals x. And so I'm going to do that right here and right here. And you notice that the lengths are the same. In other words, this point here on f inverse of x is the same distance away from the y equals x line as this point. And that's going to be the case for all inverse functions. Okay, example 2. We have f of x equals x squared plus 1. we want to find the inverse function and specify the domains of both functions. So we'll start finding the inverse function first. So y, let me write it over here. So y is equal to x squared plus 1. Switch the variables. X equals y squared plus 1. Subtract 1 from both sides. X minus 1 equals y squared. Then you take the square root of both. So we have the square root of x minus 1, make sure they're both under the radical, is equal to y. Now, look at the domain. Well, this is f inverse. Now, what is the domain of this? Well, x has to be greater than or equal to 1. So we're going to put that domain x greater than or equal to 1. Now, look at the domain of f of x. Well, that would be all real numbers. So we're going to take the least or the most restrictive. We have to go with this domain on the f of x, or the f inverse of x is greater than or equal to 1. Okay, so now let's plot these functions. We'll do xy table for f of x. So that's x squared plus 1 xy table. So when x is 0, y is 1. When x is 1, 1 and 1 is 2. When x is 2, x squared is 4 plus 1 is 5. Okay, so let's plot those. 0, 1, 1, 2, 2, 5, 2, 3, 4, 5, 2, 5. Now let's do for f inverse, which is the square root of x minus 1. We're going to do an xy table. So when x is 0, we can't have it be 0 because we've already said it has to be greater than or equal to 1. And so this point here on the xy table for x squared plus 1, the 0, 1, don't think I'll be able to use that. But let's continue with the f inverse. So x is greater than or equal to 1. So when x is 1, square root of 0 is 0. When x is 2, 2 minus 1 is 1, square root of 1 is 1. When x is 5, 5 minus 1 is 4, square root of 4 is 2. Let's plot those. So 1, 0, 2, 1, and 5, 2. 2, 3, 4, 5, 2. So after we graphed them, we can tell on the inverse function, that's f inverse, is that one, we know that the domain is x is greater than or equal to 1. But when we graphed the f of x, we found out that x can be 0, and so our domain on this is domain is x greater than or equal to 0. The other thing to notice on these xy tables, they're reversed. So the point 0, 1 right here becomes 1, 0, so on and so forth. 1, 2 becomes 2, 1. 2, 5 becomes 5, 2. Now let's go ahead and graph these, and you can see that they're going to be a mirror image of each other, or reflect each other about the x or y equals x axis. So let me try and draw these or sketch these in, something like that, and then it's going to go like that. So they're a mirror image reflecting on the x equal y or y equal x axis. Okay, this is it for 1.9 day 1.